Hello, good morning. We are going to continue from where we stopped last time. Our discussion today is on molecular formula, specifically finding the molecular formula of compounds. Finding the molecular formula of compounds is our topic today. By the end of this lesson, you should be able to find the molecular formula of compounds. Please, in the last video, we treated empirical formula. So if you don't watch the video, I advise you go back and watch the video because it will help your understanding in this present video. Okay? Now, in the last video, we started with glucose, and that is what we are still going to do today. Glucose, just like many other substances, is a chemical compound, right? And we are familiar with this glucose. Remember last time I said that since it's a chemical formula, since it's a chemical compound, it has the molecular formula C6H12O6. So in a molecule of glucose, we have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. If you look at the formula, you find that you have 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Now, from there, the ratio of carbon to hydrogen to oxygen is 1:2:1, and that is how we got the empirical formula. But we are not interested in the empirical formula today. Our concern is in the molecular formula. Molecular formula is that formula that shows the actual number. And in glucose, the actual number of the constituent atoms is 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. So that formula that shows the actual number of atoms of different elements in a compound is called the molecular formula. So molecular formula is the formula of a compound that shows the actual number of the constituent atoms of the different elements. Now, if you recall our empirical formula, you find that, okay, this is the empirical formula of glucose, CH2O. This formula shows only the ratio. Now, if you look at the molecular formula, you find out that the molecular formula is like multiplying this empirical formula by 6, right? If you multiply the whole empirical formula by 6, you have C6H12O6. So molecular formula is a multiple of empirical formula. That is, molecular formula is like a duplicate of a multiple or numerous empirical formulas will give you molecular formula. Do you understand? Now, that is not even the issue. The issue where students get problem is when they are asked to find the molecular formula, giving some parameters. For instance, look at this example. An organic compound has the empirical formula CH2 if its molar mass is 42 grams per mole. What is the molecular formula of this compound? Given that H has atomic mass of 1 and carbon has atomic mass of 12. Now, things you need to know whenever you are given this kind of question. Things you need to know if you are asked to find the molecular formula of a compound. First, you have to identify the empirical formula. Second, you have to know the molar mass of the compound. These are the 2 things you look out for whenever you are asked this kind of question. Now, from our question, the empirical formula of the compound is CH, right? And the molar mass of the compound is 42. Let's see how we can use these 2 parameters to solve this problem. Recall in our previous video that empirical formula times N will give you the molar mass. And the empirical formula of the compound given to us is CH2. That's the empirical formula. And the molar mass from the equation is 42, right? Now, using this formula, empirical formula times N equals to molar mass. We have empirical formula given to us in the equation, which is CH2 and molar mass 42. So we have CH2 into N, just like this, equals to 42, just like this one, molar mass. Molar mass of the compound is 42. Now, what this means is that if you add the masses of the different atoms in this compound, it should give you 42 grams. That is what it means. So remember also that molecular formula is the multiple of empirical formula. So this is like molecular formula skeleton. If you add the masses of this atom, it should give you 42 grams, because the mass of that molecule or that compound is 42, right? Now, what is the mass of carbon atom? It is 12. The mass of hydrogen is 1. So we have 12 here, plus hydrogen is 1, but we have 2 atoms of hydrogen here. So we have 1 times 2 into N will give you 42. Remember, we said that molecular formula is the multiple of empirical formula. So this N means that multiple. We have to find that multiple before we can find the molecular formula. So finding N. We have, from here we have 12 plus, this is 2, 1 times 2 is 2. So we have 12 plus 2 into N equals to 42. So we have 14N equals to 42. How do we find N? Divide both sides by 14. So you divide this by 14, divide this by 14. Sorry, this should be 14. This should be 14. Good. This will give you N equals to 3. Now, that multiple is 3. Let's bring it back to the empirical formula. Molecular formula is the multiple of empirical formula, right? So this is the empirical formula, and that multiple is 3. Excuse me. So we put 3 here. N is 3, so we put 3 here. How do we now find the molecular formula? Multiply through by 3. So 3 times carbon atom, we have C3. We have 3 times this 2, we have H6. So the molecular formula of the compound is C3H6. Do you understand? So if the empirical formula is just CH, the molecular formula is C3H6. That is the multiple of empirical formula. It's just like bringing the empirical formula 3 times. That's C3H6. Okay? Good. Now let's try one more question and we'll end there. This should be molecular formula. What is the molecular formula of a compound with the empirical formula CH2O and vapor density of 30? Remember, things we need to know: the empirical formula and the molecular mass of the compound, right? Now we know the empirical formula, which is CH2O, right? And the vapor density is 30. We need the molar mass or the molecular mass, not the vapor density. So how do we find molecular mass so that we can find our molecular formula? Now let's see the relationship between vapor density and molecular mass. Now, empirical formula is this. Good. Molar mass is equals to 2 times vapor density. So if the vapor density given to us in the equation is 30, the molar mass of the compound is 2 times 30, because molecular mass or molar mass is 2 times vapor density. So we have 2 times 30 to give us 90. Now the empirical formula of the compound is CH2O and the molecular mass is 90. We can now find our molecular formula, right? So recall too that empirical formula into N equals to molar mass. molar mass is 90, empirical formula is this, into N. So what is the atomic mass of carbon? 12. So we put 12. Plus the atomic mass of hydrogen is 1. We put 1 times 2. This atomic mass was given to you in location, so nothing to bother. Then times 2 plus atomic mass of oxygen is 16. If you add everything and multiply by N, it should give you 90. That is what it means. Now, it should give you 90. Now, we said that we need to find the molecular mass, right? Okay, molecular mass is 2 times vapor density, right? So 2 times 30 should be 60. Sorry about that, not 90. This should be 60. So this is 60. So this will affect our answer. So this is 60, 60, because 2 times 30 is 60. That's a mistake, okay? Okay. Now, we have 12 plus 1 times 2 plus 16 into N will give you 60. 12 plus 1 times 2 is 2, which will give us 14. Plus 16 will give us 30. So we have 30N equals to 60. We have N here, so we multiply by N. 30N is equals to 60. Okay? So N is equals to 60 over 30, which will give us 2. Alright? Now this is N, that multiple we are looking for. So molecular formula, which is the multiple of empirical formula, becomes empirical formula times N, right? So times N, what is our N? 2. Good. So it will be 2 carbon atoms, that's 2 times C, 2 carbon atoms, then 4 hydrogen atoms, and then 2 oxygen atoms, right? Because 2 times this will give us C2, 2 times H will give us, 2 times 2H will give us H4, and 2 times oxygen will give us O2. We are looking for formula now, not mass. So we are not multiplying mass, we are just writing out the symbols and the multiple. Remember, formula of a compound is just the symbols plus the number of times they appear in that compound. Okay, the symbol of element times the number of times they appear in that compound. So the molecular formula of this compound becomes C2H4O2. Good. I hope you understand. Alright. Now, in the next video, we are going to solve more practice problems on both empirical formula and molecular formula. But for now, try your hands on this study question and let me know what you understand. Okay? If you want to get more of this kind of videos, like and follow our page, Ask the Teacher, Ask the Chemist. And I will see you later. Okay? Thank you for watching. Bye.